Hey, academias, of course, welcome to Study with Mr. M, known as the Maths and Science Academy. Now, of course, I don't want to waste time. We're continuing from scenario number what? 2, we're going to scenario number what? 3. Now, scenario number 3 says that it is the ball released. Keyword, released. Keyword, released. Right? Now, of course, I'm going to change this one. There will be scenario number 3 and scenario number 4 in the same video, and I'm going to show you how. Right? Now, the ball will be released or thrown. Right? But when a ball is released, it means that there is no initial velocity. Its initial velocity is what? It is 0. This is what I say over here. Right? So there's no need for me to say it again. There's no need for me to say it again. Let me change the color. I don't like the red. Of course, let's continue. Right? Now, if a ball is released from height, which one is the first direction? The first direction is what? Is downward. So that means down is positive. That means our 9,8 is going to be what? It is going to be positive. Why? Because it always acts downwards. And if you take downward as positive, that means it's going in the same direction as the direction that we chose as positive. So it has to be positive. Do you get me? Fine. Right? But now, the velocity, do you agree with me? If you throw a tennis ball down, when it reaches the ground, when it goes, its velocity increases. I said to you, when a ball goes up or an object goes up, the velocity decreases. Right? And I said to you, when a ball or an object goes down, the velocity increases. We could think about it like this. The gravitational acceleration is acting in the same direction as the gravitational acceleration acts is negative. Let's do this. The gravitational acceleration is going down, and the gravitational acceleration here is going down. So you can see over here, right? When a ball goes up, the velocity decreases. Why? Because the ball is trying to go down, is trying to go up, but the gravitational acceleration is trying to go down. So they are opposing each other, slowing down the ball. You could think of it like that, right? Then the same thing happens over here when the ball goes down. Let me remove this. When the ball goes down, the velocity increases because it is acting in the same direction as what? As the gravitational acceleration. So it's making it more faster. We can think of it like that. Right? Now, let's continue. I want you to look at something over here. It means that over here, we will be displacing positively. Right? Because we'll be end up being lower than where we started. Down than where we started. And what did we choose as down? Down is positive, meaning our displacement is going to be positive. Right? So when we displace, it means that our displacement is going to be increasing positively. Right? Now, I will say, we're going to the ground. What do you mean our displacement is increasing? I said to you, look at it like this. This is you. You throw the object down. Right? If you take this from the point it started from to where it is, let's say here, from the point it started from here, right? What is the distance between the ball and the surface here? It is 0. There is no displacement. But when the object goes from where it was to another point, can you see the displacement now? The straight line, the displacement is increased. And when you go lower again, can you see the straight line displacement over here? It does what? It is increased. So when you draw your position time graph, you also have to show that the displacement is increasing. This is when you take this point as the 0 reference, the height as the 0 reference. But if you take the ground as the 0 reference, I'm also going to be showing you on what we do. Now over here we don't have maximum height because the ball does not go up and decreases the velocity until it reaches 0. So there is no maximum height, so there is no Vmax. But it's just a simple type of thing that you need to know. But you also need to remember that the displacement will increase, and I just showed you why I mean when they say it increase, because we know that displacement is not the same as height, so it's just a change in position of the object. Now the graphs are too far, but let me draw the motion of the ball so we can see that here. Let's see here. Now you must take note. Right, you must take note. How do we draw the position time graph? The position time graph must take the motion of the what? Of the object. Now, if we take the height, the point it starts from as 0 reference to wherever it ends, it means that the displacement will be larger. The displacement from where it started to where it ends is increased, right? Now, it has changed position larger than where it started from, right? That is the definition of displacement, the change in position of an object. I've been explaining this, guys. Now, it means that you have to show them that, yes, what did we choose? We chose down as positive, right? So if our down is positive, it means that we can show them like this. We can say that our point that we start at is 0 reference. So you have to have something like this. Maybe the increase to show the increase, or maybe you can have something like this, right? Something like that to show that the displacement increases, right? Now when you take the ground as 0 reference, right, what is going to happen is that your ball will now start at a certain height, because now the certain height is no longer the 0 reference, right? Now the ball is going to go down up until it reaches the 0 reference point, right? But that also would be the same if we chose another direction as positive. So if we chose up as positive and down would be negative, so you do the same thing over here, right? The displacement would decrease towards it would increase towards the 0 reference point, which would be the ground. I explained why I'm saying that displacement increases, because the change in position from where it started from to where it ends, it has increased, right? Now let me show this one. You can either show this one or you can either show this one. It's the same, right? Now what you must remember, the velocity time graph takes a straight line shape, right? So if you remember over here, what is going to happen? The ball is released, so it starts at 0. The velocity is 0, right? There's a reference point, the 0 reference point, whatever. It is only for the position time graph, so don't stress, right? Now it is only for the position time graph. Who they want the most is this one and this one. This one is just if they ask you about it, it will be just 2 marks, 3 marks. It's fine. But this one you can get 6 marks, 7 marks, 5 marks for this one, and also this one can be 7 marks, 5 marks. It's high marks if they ask you to draw it. Sometimes they don't even ask you to draw it, but you always have to be on the safe side. You have to know it. You're part of the academy. You have to know it. I'm just joking, right? Now, if you remember, the velocity is going down. What do we say about the velocity when the object goes down? The velocity will increase, right? So the velocity has to increase until it reaches the ground, right? Why are you going in the positive part? Because we did choose down as positive, so it's fine for us to draw it over there. If we chose down as negative, we would say that the object increases but in the opposite or negative direction, like that. But now we have the right to do it because we chose down as positive, so downwards movement is shown in the positive part. That's what I'm trying to show you. Simple like that. You see, guys, it's really not complicated, right? You just show it like that. If you want to be technical, of course, you can show them dotted lines over there. And if they say maybe you find the time it takes to reach the ground, you'd show the time. It's fine, right? Now, I was waiting for this. Here, I want you to take note. Here, which direction do we choose as positive? We chose down as positive. Down as positive, meaning our acceleration is what? Is positive. So we have to draw our acceleration on the positive side. So we can say 9,8. And now it means our acceleration is going to be positive over there. Right? And I said to you, it will always be a straight line. It will depend on which direction you take. It will always be just a horizontal line, flat line. It's fine. Right? So that is just scenario number 3. Now let's go to scenario number 4. Let's just do scenario number 4. Let's say ball thrown instead of not equal to 0, of course. What can we change? The velocity is greater than 0, of course. Increase. Now, a lot of things do not change, but the graphs will change a little bit. So no, the graph, they won't change. This one will change. And this one also won't change. Now, if now the velocity is greater than 0, so there is a velocity, right? There is a velocity. The ball is now projected. It is given an initial velocity. It is thrown. It is given an initial velocity, right? Now, if you want to draw the velocity time graph, it has to start at that initial velocity, right? Which velocity is that? Let's say it's here. And it still does the same thing. It's going down, so the velocity is going in the same direction as what? As the gravitational acceleration, so it must be faster. So the velocity must do what? Must increase. So it increases again until maybe a certain time, right? And then you show the dotted lines to be technical, right? So this would be your A, and this would be your B, right? And also over here, this would be your A, and this would be your B, right? If you take the ground as a reference point, 0, you'd say this is your A, and this is your B, right? Fine, right? Okay. Because if you take the ground as 0 reference, it means that the displacement between the ball and the ground would be 0, and we know that the displacement here would be 0. You don't understand that? Okay. You're not studying. You're not listening. If you don't understand what I just said, you have to go back. I'm just playing, guys. Now, scenario number 4. This was scenario number 4. The one that I was throwing. The scenario number 3 was when I was still releasing. That was fine, right? So you must take note of the graphs. The graphs are the ones that are very, 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 very important. So I don't know, but I think I did justice to the scenarios. As I said, guys, it's a lot of scenarios, and we'll keep going through each and every scenario until we finish them and understand each and every scenario and each and every graph, right? That's the same. Now, let's just, oh yeah, still the same thing. If they ask you to find maybe the height of the building, you'd find the displacement of the ball, because it would be from here to here in a straight line. So that would be essentially giving you the height of this building. So if you find the displacement of this ball X from A to B, it will be essentially giving you the height of the building. Of course, that was a key point. You must take note of that. Guys, we're doing VPM very nicely. I think this is a good approach. These scenarios will help us, because it helps those who don't understand the graphs understand the graphs for different scenarios and see which, if it's like this, I do this. If it's like this, I do this. So that when we get to the high order questions, at least the basic is strong enough. See you next time.